Welcome back. In this section, we'll learn about breadth first search. We'll cover the following videos in this section. In the first video, we'll understand the application that we'll be developing. In the second video, we'll understand how to represent connection data as a graph and what is graph data structure. In the third video, we'll understand queue data structure, which is used by BFS algorithm. In the fourth video, we'll understand how BFS algorithm works and what are the steps. In the fifth video, we'll evaluate the key differences between DFS and BFS algorithms and understand how to decide which one to use. And in the sixth video, we'll look at an application which you'll try to develop by yourself. In this video, we'll learn about LinkedIn connection feature and how it works. We'll look at the application, how it works, and the changes required in state class for this application. LinkedIn is a social network. Suppose I want to find an acquaintance called Jill and connect with her. When I go to her profile, I find that she is my second degree connection, which means we have a mutual colleague. Let's see how this number is computed. So let's try to create a connection tree. So first of all, we start off with my profile node and add it to the connection tree. Now I find my colleagues and add them under my node. So I add Ali and Tom under my node. Now for both Ali and Tom, I find their colleagues and add them under their nodes. So under Ali, we add Dev, Seth and Ram. And under Tom, we add Dev, Seth, Kai and Jill. Now for each of these nodes, we find out their connections and add them underneath. Now Dev's connections have already been added here. So due to space constraint, I'm not showing this here. So for Seth, we find out his connections and add them underneath. So we add Ali, Tom and Harry. And for Ram, we add Ali and Jill. Similarly, due to space constraints, I'm not showing Dev and Seth. Seth has been shown here. And under Kai, we add his connection Tom. And when we come to this node Jill to add her connections, we find that this has cold state. So we end our search here. If you notice, then Jill appears here as well in the connection tree. And if we consider this node, then the connection degree is 3, which is not the least value. But because BFS search processes the search tree level by level, we're able to find the least path solution. We also see that there are multiple people which appear multiple times in this connection tree. For example, Dev appears here, here and here. Ali appears here and here and here. Tom, Seth, and Jill. So we'll keep the first entry of the node in the connection tree and remove the other instances. Now this is how the search tree should look like. Actually, when we add the node to the search tree, we should check if it previously exists in the search tree. In the section Depth First Search, we learned that state class indicates the condition of search process. We also learned that the state class has to be changed for every application, even though the search algorithm is the same. Let's see the changes that we need to make to state class for this application. First, we need a property to track the condition of search. In this case, it is the person under consideration. And then we have the same 4 methods: constructor, get initial state, successor function, and check goal state. Let's see these 3 ingredients in detail. To find initial state, we ask ourselves the question, where do we start searching from? In this application, we start searching from my profile. To find the successor function, we ask ourselves, how do we explore from the current state? In this application, this function should return the people connected to the person in consideration. So, for Ali, it should return all his colleagues. And to find the goal function, we ask the question, how do we know we found the solution? In this application, the goal function should return true if the person is Jill. So if the current person is Harry, the function should return false, and if the current person is Jill, it should return true. Let's see the state class code for this application. In this module state.py, I'm importing all the variables from graph data. The purpose of graph data will be explained in the video graph data structure. In the constructor of state class, the argument name is passed. If name is none, then the initial state is created. And if name is provided, that name is assigned to the name property. Initial state is my name, and successor function returns all the people connected to the current person. To get the people connected to the person, we use connections from graph data. We'll understand how exactly this works in the video graph data structure. In check goal state, we see if the current person's name is Jill and return that. And in the function check goal state, this function returns whether the current person's name is Jill. Let's recap what we learned in this video. We understood how degree of connection is computed, and we understood how the state class is changed for this application.